The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
To start out this session, we would like to dedicate the session to M.K. Hurd. She was born in 1926 and passed recently in 2013. Mary Kay Hurd was a graduate from Iowa State University in 1947 with a Bachelor's of Science degree in civil engineering. She was a pioneer in engineering and construction journalism. Quoting Mary, "They didn't look at me seriously," she said. She had been the only female graduate in her class and was an excellent student. She would have qualified for Tau Beta Pi, but the women weren't allowed into Engineering Honor Society at that time, and most companies were not interested in hiring a female engineer. One of her professors knew the American Concrete Institute in Detroit was looking for an engineer who could write well. Hurd had writing experience as the editor of Iowa State's Iowa Engineer magazine. It was a perfect fit, except that ACI did not want a woman. Her professor finally convinced the association to hire her, and thus began her lifelong association with ACI. She didn't plan to write a book in the early 1960s, but she was asked to meet with the Committee 347 to help with the publication. Quoting Mary, "I thought it would be like a typical engineering book with chapters written by different experts." She recalls, "That's not what they wanted. They wanted me to write the whole book." I did not want people not to buy the book because it was written by a woman. So what she did was went by M.K. Hurd, and most people who bought over 130,000 copies didn't know that a woman wrote the book until years later. It was on its 7th edition, and now currently the 8th edition by another author. It was known in construction communities as the Bible of construction industry for the formwork for details, design, materials, and planning of formwork. She was recognized alongside Thomas Edison by the Engineering News Record as one of the construction industry's top 125 people of the past 125 years. The image is just showing Thomas Edison's concrete house that he had patented, and a picture of Thomas Edison. She was the first female to receive the Anison Marshall Medal, the highest award bestowed by Iowa State's College of Engineering. Unfortunately, she passed a few weeks before receiving that award. She also received Iowa State's College of Engineering Professional Achievement Citation in Engineering. She was the past president of Concrete Improvement Board of Detroit, Michigan, and the Michigan chapter of ACI. She received Concrete Construction Magazine's Lifetime Achievement Award, ACI's Delmar Bloom Distinguished Service Award twice, ACI's 1995 recipient of the Henry S. C. Turner Medal. She received several construction awards, and she was recognized not in her industry not only as a pioneering woman, but an expert engineer. She ironically was asked to be a keynote speaker several times for the Engineering Society Tau Beta Pi, and she also spoke several times for the Society of Women Engineers. She was a life member of the American Society of Civil Engineers, the Precast Prestressed Concrete Institute, the Construction Writers Association, and the Concrete Society of the United Kingdom. I chose this one article that she had written several years ago about a driveway. And the reason why I did that, I thought it was she allowed her home to be part of a research project for her driveway, for research on white topping residential driveway. And as the Concrete Construction magazine wrote, They had heard from their old friend, Mary Kay Hurd, as the editor of this magazine during the 1980s and 1990s. It reminded them of an article she wrote in 1990 about white-topping an old asphalt driveway at her home in Michigan and asked how it was holding up. Her memo inspired me to take a look at the driveway, as the concrete construction person wrote. That she replied, "There's only one crack, though it opened up a bit. All of the joints have opened some, and I now recall considerable discussion with Pete Contros, among others, about whether or not to seal them. Today I'm glad we didn't. What maintenance issues might there have been? Pop-outs were a really early concern, but haven't really led to any further deterioration." So I only fortunately got to meet Mary for a short period of her life, but she really impacted me greatly through ACI 124. I know others have much better stories than this. One of the last ones that I wanted to share with you was her working with several individuals on formwork. And usually, if we had a chance, we'd ask her to sign our formwork book. And most of the men engineers or contractors later found out that after she had written it and how well written it was and followed, that they admired her greatly and would ask them to come to the job sites to work out details when they were needed. And so this is an image of her just a few years ago on a job site. The one on the right is working out some of those details. So at this time, with her passing in the concrete industry that she was knighted in the U.S., we, the ACI 124 Committee on Aesthetics, would like to dedicate the session to M.K. Hurd. At this time, I'd like to introduce Robert Weinstein.
Hi, I'm Robert Weinstein. I'm a principal of Architrave Architects, and I'm here to tell you today about a project that we did at Meridian Hill Park, which was to restore the concrete and try to patch to match. And so that will hopefully answer your question. Let's see, where are all these devices? Anyway, okay, that works. Meridian Hill Park is a National Historic Landmark, and it's because of its concrete. And I thought that was pretty neat. I mean, to think about having a National Historic Landmark be a National Historic Landmark because of concrete. And it may be the only one of its kind of that for that particular reason. And it was because John Earley was able to do such incredible things with the concrete. And you can see this is taken just within the last couple of months. This is one of the entrances to the park. That some of his concrete, which is over 100 years old at this point, holds up a lot better than some of the concrete that I've seen that poured in the last 2 years or the last 10 years. And it's really a remarkable achievement. It took about 21 years to put the park together, and I know that there were several different contracts and several different contractors, and I'm sure that they were all on time and on budget, and that they tried to keep things moving a little bit. We were very fortunate to work with the National Park Service, and we did several projects at the park. In addition to the restoration of the concrete. The first one was a cultural landscape report, and if you don't know what that is, it's like a historic structures report, except for it's for a landscape as opposed to just a simple structure. We also did restoration of the lodge, and this lodge was just like an open gazebo before we did the infill work. And that was to create accessible toilet rooms and a place for the park police. In addition, we did a restoration of the fountains, and we also did a final project, which was correction of drainage and landscape drainage. So the park was a 12-acre site, and we divided it up into the different times, the different areas relative to the different periods of construction. It also has like an upper terrace and then a lower terrace and then the cascades and those sorts of things as well. But it was a 12-acre site, and we had to survey that entire site. So the first thing that we did was that we cataloged all of the mixtures that were used, and we gave them names. And this is just a visual observation, just going out and visually looking. And has everybody here been to the site, or has anybody not been to the site? If you've not been to the site, oh my gracious. So if you don't do anything else while you're here in Washington, go to Meridian Hill Park and look at the park. It's an Italian hillside garden in Washington, D.C., and one of the best kept secrets from all of the tourists. So go in the daytime, especially on a day like today if you can. But when you look at it, it all kind of looks pretty much the same. And then when you start really looking at it, you start to appreciate all of the differences and all of the different aggregate combinations. And so we did this survey, and then we gave everything a name. And this was the mix that we called Al, and that was our first, or one of our first mixes. And it was kind of like Adam in the Garden of Eden, where we were naming all of the creatures, you know. So anyway, but we found that there were really just 4 basic types of aggregates, and those were washed stone and crushed stone in different sizes. And then he added things to those. He added either quarry tile, or he added little marble chips, and then he would combine them in different ways. And so, I have this right in front of me. We inventoried the mixes which were used in each of the 4 types. Each of the 4 types of what? So we, again, in our cataloging, we divided up the surfaces, and we had walks and steps. Then we had walls and piers, so those were vertical. We had the walks and steps, and curves was horizontal. And then architectural features, and then the decorative elements. And the decorative elements were mostly precast, whereas most of the rest of the stuff was site cast. And this is now I'm going to just run you through a sort of a series of some of these decorative elements. And you can see on our survey form, this is a concrete mix AP, which is different. It's a decorative element, which is highlighted in red. But we also identified whether the surface was a horizontal surface, a vertical surface, it was flat or curved, whether it was precast or site cast, and which construction period that it was done in. So we had all of these different mixes and different types in different places in the park, which we cataloged. So this is AML, good old AML. And then here in the pavements we find a combination of a lot of different things to achieve the patterns. So we have a concrete mix DB, DC, DT, and DW all put together to create this beautiful pattern in the horizontal surface. And then here, this is where you can see the little pieces of quarry tile within the matrix of an otherwise kind of gray aggregate surface. Here's one with some more joint work in it. After creating our catalog and naming everything and having names for everything, it was time to do a survey. And we did a very, very detailed survey. We surveyed every crack, every spall, every delamination, every place where there had been a previous repair that did not match, it hadn't been done properly. And this is a picture from the vertical surfaces survey. And in addition, on the vertical surfaces, we noted how high we were above finished grade. Because we're thinking always now, what information does a contractor need to know when he's going to put his bid together? Well, if he's going to have to provide scaffolding to make the repair, that's going to be a different situation than if he's just going to be able to do it from the ground. And this is our crew. They really got into the cracks. I mean, there was thousands and thousands of them, so they had to be dedicated. And some of the work was pretty cold, and we did some of it in the winter. And then after spending all of that time in the field, or even to come in and get warm, we took the information from our surveys and we quantified it from drawings to spreadsheets. And these are Excel spreadsheets, and every single crack was named. And if you know about, well, you're concrete people, but if you know anything about fire alarms now, the big thing is addressable systems, where each device has its own name. Well, this was an addressable system. Each crack had its own name. Each spall had its own name, and we had pages and pages and pages of definitions. I know you're not really supposed to do this, but I'm going to do it on this slide, which is actually just read you the slide because it's kind of summarizes what we did. There were 508 cracks, which took 16 pages, 17 delaminations, which took 1 page, 214 areas of efflorescence, which took 7 pages, 22 cases of previous repairs, 1 page, 661 spalls, 20 pages, 321 instances of deterioration of the piers, 11 pages, 97 instances of deterioration of the benches on 4 pages, a total of 1,840 types of deterioration and 60 pages of Excel spreadsheets. And we called this, I called it really a crazily, seriously comprehensive survey. So now we had named everything and quantified and cataloged everything, and then we had surveyed everything to determine what the levels of deterioration is. Now we had to start thinking about, well, why is it deteriorating? And so we got involved with CTL, the construction testing people, and they took core samples, and they took both core samples from the deteriorated pier that you see here, but also core samples from a wall which was in good shape but built in the same time period. Now, the one thing that this helped us do was to eliminate ARS. This is when I first understood and discovered what ARS was, which was this alkaline silica reaction. And we said that's not the cause of the deterioration here. The main cause? Who knows, right? Freeze thaw. As always, water is our enemy. So you have to remember we were working for the National Park Service, and the National Park Service unfortunately never has enough money to do everything that needs to be done. And the National Park Service likes to document everything that they do and every decision that they make. So we created an evaluation matrix to help us decide what needed to be done first, what things we had to do, what things we might want to do, and what things were most important to do first. And of course, safety was the first thing, and it trumped everything else. So if there was concrete that was overhead and it was spalling and it looked loose and it looked like it might be dangerous, that got a very high rating, and it got to be done. Steps, tripping hazards, places like that, those also got to be in the first order of priority of business. But in addition to that, we were able to did what I called stitch in time, and this was mostly on the horizontal cracks in the pavement because it was such an extensive amount of work, where we just put in a flexible sealant that would help keep the water out and slow down the rate of deterioration. And then we were able to, as part of this first round of stuff, do a lot of patching and then the reconstruction of, I believe, 3 out of the 4 piers. And so that was kind of the entrances to the park. We tested all of the methods, all of our proposed methods of repairs at the park. There was a lot of cleaning that needed to be done. There was heavy efflorescence. There was a lot of graffiti. And we followed the Park Service's guidelines and started with the gentlest means possible, which did almost nothing. And we ended up with a Joss machine, which is a kind of a circular head. And the Park Service had the machine, and you can choose different kinds of aggregates. It makes a big mess, but, you know, if you use walnut shells, they're eventually okay. But the Joss machine was the only thing that could take off the really, really heavy calcium buildups that were where the water had been washing through the wall. And it would take off the graffiti, and you could control it and take off one level at a time without actually destroying the historic fabric. On the horizontal and vertical crack repairs, I already told you on the horizontal the basic thing was just stitch in time. The vertical cracks, we ended up using neon patching material. And that was, they would get things that matched the color and matched the type of thing. But the hard work was the spall repair and the reconstructions, because we had to have mixes that would match and that would look right. So that's when we began working with Bob Armbruster, and Bob, I think, is here with us today, and I'm glad to see him here nodding, and I'm glad to see him again as well. And he really, in my mind anyway, is still kind of the #1 authority on John Earley's concrete, and he consented to work with us and help us figure out how to patch to match. And out of the whole park, we picked the 12 most dominant mixes, and we tried to see if we could match those. And so his job was to find the aggregates, and that was really the first really hard thing to do, and then to develop the mixes. We've already been told, the previous speaker, that it's gap graded. This is a slide that Bob had created, which kind of illustrates what gap graded is. Basically, what I'm about to talk to you about is kind of what Bob went through. In order to find the aggregate, Bob took about 6 months. And let's see. He consulted with leading national distributors of decorative aggregates in the concrete industry. He ordered 100 and 200 pound bags of the 12 best candidate aggregates. He called all of the quarries and the stone suppliers listed in the phone books near the quarries that best match. He visited 6 other active quarries. He made 50 different mixes from the best candidates and chose 7 suitable to match the target mixes. He made trips to 2 libraries of aggregates. He compared more than 700 samples. He searched through 250 photographs of decorative aggregates. He contacted the terrazzo houses that obtained samples from their libraries, and he contacted aggregate associations in Maryland, Virginia, and Pennsylvania, and the state geologists. He spent 6 months searching. And so, the takeaway, selecting aggregates for repair is a combination of science, art, and persistence. And I'd say that persistence is the really hard part of that equation. And it was necessary because, remember, we're working up towards having a contractor do work. And we couldn't ask a contractor to do that work. I mean, where would he begin? How would we know, how would he know where to begin? And so Bob made lots and lots of samples. And then he made lots more samples. And here he made it. He was able to make mixes that match the historic mixes. And I spent time out there with him on the site, and we would go and we would look, and this is a little too this is a little too that, a little too that. But all of his mixes we recognized and we knew were never going to be like cookbook. That a contractor, because the humidity changes, in one of our best sources of supply, one of the quarries that Bob found, closed between the time that he did his work and between the time it went out to bid. So that we knew the contractors would still have to do their own work and their own experimentation. So ultimately we made a board of, it was like a range, a board that showed a range of different mixes, and the contractor could start with that as a starting point. So the next thing we had to do was to prove or to show that we could replicate the process and get the same fineness of edge and the same detail that Earley was able to achieve. And so we, again, before we demolished a pier, we were going to reconstruct the whole pier. We wanted to make sure it was thoroughly documented. I always thought this was just a beautiful drawing done by CTL. It was crack mapping, and they did it in color. It's very nicely rendered. And then, of course, the standard, very highly dimensioned drawing. And then we hired C.A. Lindman, who is a local contractor, masonry contractor, and he took Bob's formulas and mixes and then worked with him in his own way, and he started small, making small pieces of formwork. His formwork was like cabinetry. It was beautiful. And these guys were great to work with. And then they took their formwork to the site to check their results and to see how it came out. Then they made larger trials in their yard to see what kind of problems they were going to run into, and then lo and behold, they were able to do it. We started this pier. This is a reconstructed pier at dark 100 in the morning because they wanted to have it. They figured how long it would take before they stripped the forms, and even with all of their planning, the bottom hardened too fast, and then they had to call up and have somebody bring in a pressure washer, to try to get the stuff off that didn't come off with the brushes. But they did a great job, and they got the results that we wanted. And then we documented every bit of it, every bit of the way. Luckily, I say luckily, a piece of the corner fell off when they stripped the form. And why was it lucky? It was because then we could figure out, well, how do you fix that, right? And we could document that process to tell the contractors before they got into it. And here are the workmen, again, C.A. Lindman's guys, and they're making this repair, hand placing every piece of stone to get it into the corner to get that repair. Who would know? It looked pretty good to me. So this is a sheet of our working drawings. The next step was to go out to bid. We actually divided the project into two parts. One, just all of that horizontal stitch in time, and then the other was the important concrete work. And here's a detail from the contract documents of the partial reconstruction of a baluster. And here's a real baluster. This is not a reconstructed baluster. This is just a sample of what the real balusters look like. Here's the edge of the fountain bowl. And again, this whole edge had deteriorated and had fallen off. And here's what the fountain bowls look like. And it's the real thing. This is a funny story about construction sequence. It has nothing to do with concrete. But the contractor was anxious to, get started and get some money. So the first thing he did was he demolished all of the wood slats off of all of the benches. And then he didn't do anything for about a year while he figured the rest of the project out. And believe me, the neighbors were angry. Not bad for concrete. It's really a beautiful place. And I'd like to thank, actually, Judith Capon, who's the co-author of the paper, who's sitting here with me today, Bob Armbruster, who participated, but also Dennis McMullen was our structural engineer, and he was the one that sort of got us interested in making this presentation. And Mary Ann Graham, who worked for us at the time, who's now out west making candles, who did a lot of this, the heavy lifting on this project. So here's a view from the top of the Cascades looking down, and here's, it's just a beautiful place. Again, if you haven't been there, make sure you don't miss it before you leave town. Thank you.
So the modern technology is that we could expose that aggregate in different ways using different chemical applications, etc. Was it part of the contract that they would use the Earley process of stripping the molds quickly so that the concrete was still green and then hitting them with a wire brush?
Yes, that's what we tried to do. We tried to replicate Earley's processes as best as we understood them. We did have two different types, like a pink and a green form release agent. There were two different kinds of form release agent. I didn't know this thing about the foil and the oiled cloth that you were mentioning this morning, whether that was used at Meridian Hill Park. Bob?
Yes, we required a watertight form, and of course now we can do that with some of the polyurethane epoxy coatings for plastic formwork with fiberglass as well as metals. And we also, this was a prescriptive, pretty interesting, there was a prescriptive specification, even specifying and illustrating the samples that the contractor had to make along the way. And so there were sole source materials at times, because there was only one aggregate for particular mixes, as well as very specific gradation, specific mix formulations, and all the other ingredients. But it was basically Earley's proportions with the addition of the superplasticizer. And you could also use a water reducing agent. And then lower water to cement ratios than originally used. This is pulled water out. We didn't want to write the contractor off the hook to do that. And it still had to be stripped really early. That year, they had to strip it within about 6 hours of placement.
Yeah, and they put a little hole in the side so they could watch it, you know, they had a little window. Check on it.
Honestly, these specifications all require a series of tiny, small, architectural mock-up samples because the contractor simply have to do an experience to control those variables. Yeah.
Another thing that I just wanted to say is that the aggregate problem was one where we suggested to the Park Service that they stockpile aggregate. And they said, well, we don't have anywhere to put it. We said, why don't you just bury it on the park, you know? And they said, oh, well, nobody will ever find it, you know? But, you know, it's like once you spend 6 months trying to find the right aggregate and you know you're going to have this problem and it's going to go on and on, you know, it just seemed like the right thing to do, but they weren't able to do it. Judith?
So I said, and I advocated all along, and I think the rest of them did too, is let's build all of the restorations, the recreations, as closely to Early's methods as possible, which meant I think we didn't have air entrainment. We really just tried to stay away from all of the modern methods because here we had this 100-year-old concrete, and it was on the ground. It was proof. So much for modern.
Somebody, yes.
I thought that a lot of the early things were Potomac River gravel. I think Nashville and Fountain of Time for sure. And this was also, that's sort of the main gravel? Okay, which is no longer allowed to be a source.
It was under the National Reagan Airport. That was the quarry. And not only the airport was built, and the quarry closed, yes, so you couldn't get it there. But the Potomac River environmental requirements don't let any dredging be done. So it turns out down in Fredericksburg, Virginia, there are a number of quarries sort of in a similar deposit. Washington is a geological dream for aggregate. There are lots of different aggregate deposits, so there's great variety that Earley had to work with, and many of those can still be obtained today. So the replacement aggregates came from the Fredericksburg area primarily, but to achieve the match throughout the park, as Robert mentioned, we created a palette of light to dark mixes for each pebble size. And we did that by blending 3 aggregate sources, the river gravel, Potomac tan, a dark Wisconsin flint gravel, and a more white quartz aggregate. So with the 3, by varying the amount of each, much like an artist blends different shades of colors, you could get the right tone in the mix. The other thing that was critical for color was adding pigments, because although they probably used white and gray cements, over time the iron oxides in the aggregate and sands had tinted the matrix, so that the mortar in the concrete really is no longer like the original. And the petrographic study showed that wasn't simply a surface stain that could be removed. It went through. So to get that same coloration, and we did the same on Nashville Parthenon restoration, it was necessary to use some pigments. Even though in another 50 years there may be similar kind of iron oxide staining, it just was not, it was too white, too bright initially without the pigments.
Thank you all very much.